Ever wondered how robots could work together like a well-oiled team? Imagine a kitchen where a quadruped fetches a knife, a humanoid washes it, and a wheeled arm places it in a plate, all while coordinating perfectly. This isn't science fiction. It's the cutting-edge world of multi-agent embodied cooperation. And today we're diving into a groundbreaking framework called VIKI-Bench that's redefining AI collaboration. Let's start with the basics. VIKI-Bench is a training ground for robots, testing their ability to see, plan, and act in complex environments. Think of it as a three-level challenge. Level 1, Agent Activation. It's the robot version of who's on the team. Here, the system must select the right robot for the job. Is a fast-moving quadruped better for fetching, or does a dual-armed humanoid need to handle delicate tasks? The answer depends on the scene and the task. For example, if the goal is to wash a knife, the system might activate a humanoid with arms, not a stationary robot. Level 2, Task Planning. Now, it's about how to do the job. This is where the robots get a step-by-step roadmap. The system generates a sequence of actions, like move to the knife, reach for it, place it in the plate, while checking if each step makes sense. If something goes wrong, like a robot trying to grasp a plate with a single arm, the system refines the plan until it works. Level 3, Trajectory Perception. This is the final act, tracking every movement in real time. Imagine a camera on the robot's head, an ego view, showing exactly where it's moving. The system predicts not just the robot's path, but also the paths of other agents, like a dog fetching a ball while a humanoid washes dishes. It's like watching a choreographed dance, but with machines. But how does this all work? The researchers built a massive dataset with over 20,000 tasks across 100 simulated environments. Think of it as a virtual kitchen, factory, or living room. They trained AI models using 2 stages. 1. Supervised Fine-Tuning, SFT. The AI learns from detailed chain-of-thought examples, like a human explaining, first, I need to find the knife. Then I'll grab it and place it in the plate. 2. Reinforcement learning. The AI gets rewards for correct actions and penalties for mistakes, refining its skills over time. For instance, it earns points for a clean, efficient plan, and loses points if it tries to grasp a plate with a robot that can't do it. Now here's where things get really interesting. The team introduced VIKIR, a framework that acts as a coach for AI systems. It uses a mix of symbolic reasoning and reinforcement learning to fine-tune decisions. Imagine training a robot to navigate a maze by giving it feedback after each move. VIKIR does something similar, but on a massive scale. The result? The AI becomes a problem solver, adapting to surprises like a sudden obstacle or a changing goal. The researchers tested their system with different AI models, comparing smaller ones, like a 3B parameter model, to bigger ones, 7B parameters. The results? Bigger models learned faster, but even more importantly, AI that started with some pre-training, like learning from human examples, had a huge head start. It's like giving a student a textbook before an exam. They're already ahead of the game. Of course, no system is perfect. Real-world chaos still poses challenges, like a robot facing a problem it's never seen before. And training these systems, it's like asking a supercomputer to solve a puzzle in record time. But the team isn't stopping there. They're already brainstorming smarter ways to make AI more flexible and efficient. So why does this matter? Imagine a future where robots in hospitals coordinate to deliver meds, or in disaster zones, work together to clear debris. VIKI-Bench is paving the way for AI that's not just smart, but collaborative. Next time you see a robot, remember, it's not just following commands. It's part of a team, learning to adapt, plan, and move with purpose. And that's the future.